Our today's lesson is on solving linear equations. Linear equations are like a balancing scale. Two quantities on opposite sides of the equal sign must have equal value. For example, that x plus 3 equals 10. You could think of it as x plus 3, and we're on a little scale here. And it has to stay balanced with this. It can't tilt, it has to stay balanced. In order to see this, let's consider some algebra tiles. I'm going to use this positive plus sign for positive ones. And I'm going to use this minus, this negative, as a negative 1. So think of this as positive. As positive. And this is going to be negative. And when we deal with algebra, we have two different type of tiles. This is considered x because, let's say this is x by 1. And we know the area of a rectangle is length times width, so 1 times x is x. So when you see the blue rectangle, that's going to stand for x. And if you say a square, this is going to stand for a 1 by 1 square. So when you see that, just count that as a 1. Likewise, if you see a red rectangle, it's going to stand for negative x. And this will stand for negative 1. Okay, let's apply this. Now before we get started, opposite tiles with the same value form a zero pair. For example, let's say I have a positive 1 and I pair it up with a negative. Automatically, this is a zero pair. Because 1 minus 1 is always 0. So when you see that, we can cancel those out. All right, let's apply this. Let's say I want to solve the equation x plus 3 equals 5 using algebra tiles. Now, first of all, x plus 3 is positive. So for x, I'm going to use a blue rectangle. And then 3, I have 3 ones. So I'm going to write it like this. And let's say this is my equal sign, or my balancing scale. And then notice I have 5, a positive 5 on the other side. So I'm going to put 5 of the positive ones here. All right. And what I want to do is I want to isolate the x term. In order to do that, I have to make zero pairs out of what's added to the x. So I have 3 ones added to the x. So what I need is 3 of the negative ones. But now you have to keep this balance. What I do to one side, I have to do to the other side. So what I'll do is I'm going to add 3 of these over here. And remember, these form 0 pairs. So that means I can cancel these out. It goes away because a negative and a positive is 0. And I can get rid of these. And what I have left is just 1x. And I have 2x's over here. So that says that 1x is equal to 2. So this tells me that x has to equal 2. Now, if I was asked to do the same thing algebraically, I would take this equation, but in my mind, I'll be thinking about the algebra tiles. I have a plus 3, a positive 3 added to x, so I have to take the opposite of that. That's negative 3, and apply that to both sides to keep the equation balanced. This yields 0, so I get x equals 2. All right, solve the equation 2x equals 6 using algebra tiles. I have 2 x's, so I can lay it either way. I'm going to lay it down horizontally. I have 2 x's, and here's my equal sign, and then I have 6 1's. So now I lay it this way on purpose because I'm grouping them in groups of 2. I have 6 1's, but notice that they're evenly spaced. I have 3 groups of 1's. But I need to know what 1x is. Well, one of these x's gives me 3 1's. So what that tells me is that x equals 3. I'm just grouping them. All I did was regroup the 1's. And when you divide, that's what you're doing, is grouping things together. So if you're asked to do this algebraically, you'll say 2x equals 6, and you would divide both sides by 2, or you group those 6 into 2's. So x equals 3. All right, solve 3x minus 2 equals 7 using algebra tiles. I have 3 x's. Three positive x's. And I have 2 negative 1's. So I'll put these here. Equals 7. But I have 7 positive 1's. All right. What I want to do is get the x term by itself. So I'm going to need 2 positive 1's in order to get rid of these 2 negative 1's. So but you have to keep it balanced. I added 2 positive 1's over here, so I'm going to have to add 2 more over here. Because what you do to one side of the equation, you must do to the other side. These are my 0 pairs. So this goes away. That's 0. So what I'm left with is this. I have 3 x's, and then I have looks like 9 of the positive ones. But now I only need to know what one of them equal. Again, I'm setting them up in groups of even objects here. I have 3, but now notice that 3 divides in the 9 3 times. Only need to know what one of these are equal to. So it tells me that 1x has to equal 3, because 1x equals 3 of the positive ones. So x equals 3. If I were to do this algebraically, I'll say 3x minus 2 equals 7. I would take the opposite of negative 2, that'd be positive 2. Add that to both sides. So you get 3x equals 9. Divide both sides by 3. So x has to be 3. This concludes our lesson on solving linear equations.